My topic of discussion is interference, where the lecture outline would be what is interference all about, conditions of sustained interference, methods for obtaining interference, and will give an overview of a special type of interference pattern through Newton's stream. Basically, talking about interference is that it is nothing but the phenomena of light by virtue of which two waves traveling along the same direction, having same frequency and wavelength, and also having a constant phase difference happen to overlap, giving rise to a pattern as shown in the diagram. Suppose I have one source S1, I have another source S2. According to Huygens construction, what happens? Now, if these two are point sources, light can spread in the form of spherical wavefronts from both S1 as well as S2. When they travel through the medium, there are chances of overlapping of one wavefront with that of the other. As such, at any point, suppose the point is P, there is modification in the displacement of the electric field vector. Now, the net displacement through the principle of superposition can be related as if one wave produces a disturbance from S1 at point P to be equal to Y1, and from S2 the wave produces a displacement at point P as Y2, then the net displacement in the electric field vector would be modified by superposition principle, which is given as Y is equal to Y1 plus Y2, right? Sorry. Now, what are the conditions for sustained interference? Now, the condition for sustained interference is that first condition is we need to have light coming from two coherent sources. Coherent sources means they should provide light of same wavelength, same frequency, having a constant phase difference between the two interfering waves. Also, another requisite condition is that the path difference, which is indicated by delta, should be less than the coherent length. Now, how to get this interference pattern? And can any one single source or two different sources give rise to the same phenomena? That thing we need to discuss now. That is, whether two independent sources can generate this phenomena of interference. Now, if we consider that light is coming from two different sources, they will have different modes of vibration. And it is very difficult to say that frequency will remain same. Now, how do we realize this? Or in other words, we can say two independent sources will never give rise to interference pattern. Now, it is because of the fact, consider any source. Suppose sodium vapor lamp you are taking. You have given certain voltage to it. Consider the different, move to the atomic view. You will find that it consists of number of atoms, and considering one atom, how does it look like? You have a nucleus, You have certain electrons moving in certain orbits. Now suppose one electron is excited by external electric field. So what happens? After receiving energy from external field, this is accelerated and wishes to move or orbit. It is orbiting like this, but it wishes to move in some other orbit. But there is restriction from Bohr's condition. It cannot do so. After 10 to the power minus 8 seconds, there is random phase change, due to which this electron will again return back to its original path or original orbit, which we call as the ground level. This is the excited level, this one is the ground level, and it will try to orbit around that particular orbit. Now what happens in this process? It gives rise to certain energy in the form of light. Right? So two independent sources cannot give out same frequency because we have number of such atoms with millions of electrons doing or repeating the same process, and synchronization or having the same phase is a difficult task. So what we need to do? How to achieve this condition of sustained interference? Now there are various methods for obtaining interference pattern. We'll talk about the first method. That is division of wavefront. Now in this concept, what we need to do, suppose we have any source which is a monochromatic source. According to Huygens construction, your primary wave fronts will proceed in the form of spherical wave fronts. Now in front of this source, if we place an arrangement having two pinholes almost equidistant from the source, we find that whenever this primary wavefront reaches this arrangement, every point of this wavefront which is being trapped over here, let us name this as S1 and S2, will serve as a source of new secondary disturbance. Now the same wavefront is now divided into two parts and are allowed to move. Now through S1, my new secondary wavefront will proceed further. Similarly, through S2, the secondary wavelets will proceed likewise, and there are chances of overlapping or superposition. Okay. So in this case, what happens? We had a single wavefront. Now that has been divided by an arrangement, and these two sources, S1 and S2, which we have named, they will have the same frequency as that of our incident wavefront frequency, because this is stated in Huygens construction principle, and even this frequency is same. So if they have same frequency, so now what do I have? Obviously they will have same wavelength, and S1 and S2 can be treated as coherent sources. And if they are coherent, there is chances of overlapping, and this overlapping or superposition will lead to a pattern which we call as interference pattern. This is the first method, in which what we do is actually dividing a single wavefront into two different directions by an arrangement, and then they reunite to form a pattern through superposition, which can either be a maxima or a minima, which we need to verify looking at the path difference, right? Now, This method is particularly useful for point sources. Now the second method is obviously division of amplitude. Now in division of amplitude, what we do, suppose we have an arrangement like this. I have a source, and obviously this is an extended source. I have one mirror. Two mirrors are placed. Light from source S happens to be incident on these two mirrors, get reflected, and these waves can interfere at some point, producing again modification of energy. Now in this arrangement, what we have actually divided our intensity or amplitude into parts, and they reunite to produce superposition pattern. Now this is practically true for extended sources and can be achieved through mirrors, through beam splitters, etc. Now the point P again can be chosen as either a maxima or a minima, looking at the generalized condition for interference pattern. For maxima, what do we have? If power difference is represented by delta, the power difference is equal to m lambda. What is m? It means for maxima, we have power difference should be an integral multiple of full wavelength. If point P has to be a minima one, then it is through destructive interference, and power difference has to be equal to an odd multiple of half wavelength. So these are the generalized condition for whether to judge P point is a maxima or a minima. So these are basically two methods through which we can get two coherent sources which can further give rise to certain wavefronts which superpose to produce a pattern which is called as interference. Now in this method we have Young's double slit arrangement. We have Lloyd's Weaver experiment, which are largely utilized for understanding the basic concepts of interference through division of wavefront. Now in division of amplitude part, which basically deals with intensity division, it has examples like that of an arrangement which we call as Newton's ring, Michelson-Morley experiment, etc. Till now we have covered these topics. What is interference all about? We know now what are the conditions necessary for sustained interference. We have also discussed the methods for obtaining interference. Now in our next lecture, we'll move to have an overview of our special condition which I have highlighted as Newton's ring.